Welcome to the NCERT math classes. Okay. Today we are going to discuss about the binomial theorem. This is unit 7 of the NCERT class. Okay. This is useful for the engineering entrance exams and meant for 11th and 12th students. Let's get into the chapter. Okay. What we are going to learn here: introduction, Pascal triangles, binomial expansion formula, then proof of binomial theorem, properties of binomial theorem, then exercise, miscellaneous exercise. Okay. This is a very small chapter, just like any other uh, class 11 math classes. Theory is very small, but you can find a number of examples of problems here. Okay, and variety of problems, twisted problems you can find here. Okay, we'll also learn some special cases of binomial theorem and one or two critical problems. Okay, so let's get into the binomial theorem. Okay, binomial theorem is mainly about dealing with the two variable powers. Okay, like something like a plus b whole power n. Okay, in a plus b whole power n, you have two variables, that is a and b, and power is n. Okay, we are not going to the we can expand the binomial theorem to trinomial, that is a plus b plus c whole power n, and go on. Okay, but we will learn what is about binomial theorem here. We also can get questions from trinomial 3 or 4 power also we can get. Actually, we need to understand this concept very well and put it in practice for trinomial and above. Okay, so we know this following expansions from the previous classes. We know a plus b whole square, which is, we always remember it easily, a square plus 2ab plus b square. Okay, a plus b whole cube, we still remember, we also remember this also. Okay, a cube plus 2a square b, not this is wrong actually, 2a square b, and ab square plus b cube. Okay, this is b. Okay, product, it is not in the power. Okay, and then a plus b whole power 4, maybe some of you could remember, you can form it easily, a plus b whole power 7. Yeah, you may take some time to do it, right, and so on. Okay, so expanding a plus b whole power n becomes complex for a larger values of n. Okay, binomial theorem provides a structured method. Okay, and in this chapter we focus mainly positive indices, that is n is always positive, that's what we are focusing. Okay, so binomial theorem is all about providing a structured method for a plus b whole power n. Okay, we know from the previous chapters about the Pascal triangles. Okay, how to find the coefficients of the a plus b whole power n. Okay, so this is how we find. Okay, if it is a plus b whole power 0, which is 1. Okay, so on the top of the triangle we have 1, and if it is a plus b whole power 1, then the coefficients of this is nothing but a plus b, right? So coefficient is 1 and 1. Okay, a plus b whole square, coefficients are 1, 2 and 1. Okay, similarly it goes on like this. So how did you build this Pascal triangles? Most of you already know. Okay, so first we'll write 1 here, since that is only 1, I expand it all 1. Okay, 1 and end also 1. Okay, there is no other number because this is only one number. Okay, next one is 1, I write it 1 because there is 0 here, 0 plus 1 is 1, and 1 plus 1 is 2. Okay, then 1 and 0 is 1. Okay, then for the power 3, I get the coefficients from here, 0 and 1, which is 1. Okay, 1 and 2, which is 3, 2 and 1, which is 3, and 1 and 0 is 1. Because similarly, I build this Pascal triangles. Okay, this is the useful triangle to build to find the coefficients of the binomial binomial product. Okay, a plus b whole power n. Okay, so if you see carefully, each one is a sum of above 2. Okay, wherever you don't have second one, you assume it is 0, 0, 0. Okay, okay, and it is mostly symmetric, 1 2 1 1 3 3 1 1 4. Okay, and then each term has one more than uh, the power. Okay, if it is power 5, then you will have 6 terms. Okay, so these are the things you should know. Okay, now if I replace, even in this method, the problem is, if I go back, okay, even in this method, if it is power 10, okay, and I want only middle term, I don't need all this. So do I need to construct all this to find out what is the quotient for the power 10? Whole triangle I have to construct. Okay, so there is another way. We just learned permutations and combinations. These coefficients, if you clearly see, exactly represent, okay, okay, this one, power 0, whatever is the power in that row, if you take the row is the power. So always it starts with the power C0, C1 and C2, okay, up to Cn. Okay, power, that is, if power is n, then nc0, nc1, nc2 up to ncn, it will go on like this. Okay, this is nothing but 1, this is 1, and this is 1, this is 1 2 1 1 3 3 1, okay, which is exactly same as the previous Pascal triangles we have shown here, right? So you can also get them individual values like this. Okay, so this way the advantage is, if I want to know a plus b whole power 10 middle term, a plus b whole power 10 middle term, right? Power 10 will have 11 terms, so middle term is 6. Okay, middle term is 5. If I consider 0 also, middle term is 5 will come, so it will be 10c5. Okay, 10c5 is my middle term. Okay, so simple, right? I can know exactly what is the quotient of specific term in a given power. Okay, this is the advantage of using this combination. Okay, NCR method. Okay, and now if I can write my a plus b whole power n like this, NC0, NC1 coefficients you can see, NC2 up to NCn. Okay, and the power changes like this. Okay, you take the first term to the power n, then this power will reduce by 1 each term. Okay, a to the power of n minus 1, a to the power of n minus 2, then a to the power of 2, a to the power of 1, and a to the power of 0 here. Okay, and b, second term power will increase starting from 0. Here it is b to the power of 0, b to the power of 1, b to the power of 2, and then ends with b to the power of n minus 2, b to the power of n minus 1, b to the power of n. Okay, product of all these three things. One is coefficient, then a term and b term. Okay, a term and b term. Okay, so the general term here I get is, okay, if I simply write this formula as a plus b whole power n equal to sigma, which is summation of I equal to 0 to n, nci, correct? Nci, a to the power of n minus I, b to the power of I. Okay, a power will reduce each term, b power will increase each term. Okay, and NCR is nothing but, we know, n factorial by n minus r factorial into r factorial. Remember that. Okay. So yeah, with this we can actually solve. This is the theory part. Simply this much is the theory, but you can make some special cases to easily understand the problems. Okay. The proof of binomial theorem is a very interesting part. Okay. Until few years back, you have mathematical induction as a chapter actually in your NCERT classes, but that was removed. This is a very good method to prove most of the formulae. Okay, once you know the formula, how to prove it for the integers especially is mathematical induction. Okay, in mathematical induction, what we do is basically, this is the given formula, we need to prove this, right? Okay, how do we prove? Simply, first we'll take it for 1, is it true or false, we'll check. Okay, for n equal to 1, LHS side is a plus b whole power 1, correct, which is equal to 1c is 0, a to the power of 1 plus 1c1, b to the power of 1, which is also a plus b. So it is proved for n equal to 1. Okay, now we will assume that it is true for n equal to k. Okay, which means a plus b whole power k equal to kc0 a to the power of k plus kc1 a to the power of k minus 1 into b to the power of 1 till kck b to the power of k. Okay, we assume that this is true. Okay, now we try to prove that this is also true for n equal to k plus 1. N equal to k plus 1. So what happens is, for n equal to k plus 1, LHS side is a plus b whole power k plus 1. RHS side, it will become, you take the a plus b whole power k from above, okay, multiplied by a plus b. Multiplied by a plus b, right? That's what extra a plus b will multiply. So simply do the multiplication, because this is what we get. Kc0, carefully do this, okay, kc0 a to the power of k into a. So it will become a to the power of k plus 1. Kc1 a to the power of k, because a is multiplied here, right? So each term a power will increase when you multiply with k, plus each term b will increase when you multiply with b. Okay. Now I put the color code here for a similar terms, a to the power of k, b to the power of 1, a to the power of k, b to the power of 1. Similar terms, okay, I put the color code here, so we can sum them up, right? We can sum them up. What is that? Kc0, kc0, I can write it as kc0 and kck. Okay, I can write them as k plus 1 c0 and k plus 1 c k plus 1, because both all are 1 basically, all are value 1. So I can replace them as k plus 1 c0, k plus 1 c k plus 1. Okay, that is one thing. Second one is, we should know this formula KCR, KCR, that is KC1 plus KC0. KCR plus KCR minus 1 is equal to K plus 1 CR, K plus 1 CR. This will be equal. If you want, you can take some values and try it yourself, or you can prove this also using mathematical induction, which is, you can do it actually. Okay. So if I replace, then the whole equation will become K plus 1 C0 e to the power of K plus 1 plus K plus 1 C1 e to the power of K B to the power of 1, so on up to the last term, which is K plus 1 C K plus 1 B to the power of K plus 1. This is nothing but the given equation. So with this, what I'm trying to tell is, if k n equal to k, if I assume that this formula is correct, I am proving that it is true for n equal to k plus 1 also. Okay. And I proved it for 1. N equal to 1 I proved. This holds good. So it is, I am proving it for n equal to 2. Then because it is true for n equal to 2, I can prove it n equal to 3 also true, 4 also true, and up to infinity. Okay. This is called mathematical induction method. Know it. This is helpful for you to prove many of the equations. Even though it is not there in the syllabus, you should know this method. Okay. This is the, let's see some properties of binomial expansion. Yeah, this is the binomial expansion in simple terms. Okay, a plus b whole power n is equal to sigma I equal to 0 to n, nci e to the power of n minus I, b to the power of I. Okay. Now, number of terms in the expansion are 1 more than the power. So, if a plus b whole power n will have n plus 1 terms. Okay. Then, sum of indices of a and b in each expansion term is equal to the power. Okay. Each term, a to the power of whatever is the power value, and b to the power of power value of the b, sum of these two is equal to n. Okay, something like here n minus I plus I, which is equal to n. Okay. Next is the quotient. NCR is called binomial quotient. Okay, this NCI is called, or NCR is called binomial quotient. Okay, for a minus b whole power n, every even term is negative. Okay. What happens is, when you have minus sign, actually a minus b, okay, every even term, that is first term is positive, second term is negative, okay, third term is positive, fourth is negative. So every even term is negative. Okay, something like this. Okay, a minus b whole power n equal to sigma I equal to 0 to n minus 1 whole power n. So if n is even, it will become plus. Okay, n is negative, then it will become uh, minus. So n is negative for even term. Okay. Then NCR a to the power of n minus r, b to the power of r equal to, is called term r plus 1. Okay. This is called the general term of the binomial expansion. And note down here, general term is r plus 1, not r. Okay. R plus 1 term is equal to NCR a to the power of n minus r, b to the power of r. Okay. Many of the problems in binomial theorem comes on the term, general term based, actually. General term, and where coefficient is some value they will give, or the power of some one of a or b they will give, and then find out the numbers. Okay, required numbers. These are the general problems which you get in the binomial theorem. Let's get into the chapters now. NCR chapters, these are most of them are straightforward. You can check yourself. If anything is complex, I will explain here. Let's do only the first one. 1 minus 2x whole power 5. As I said, every alternate term, that is even term, is negative. So second term negative, fourth term negative, sixth term negative. This is power 5, so you will have 6 terms. Each one coefficient is 5c0, 5c1, 5c2, 5c3, 5c4, 5c5. Okay, and then first term is 1, so 1 power anything is 1. And second term is 2x, 2x power 0 here, 2x power 1, 2x power 2, 2x power 3, 2x power 4, 2x power 5. So you simplify it, this is the answer you will get. Okay. All the expansion problems are same. Just to do it carefully without any mistake. It's the same. You expand it, mostly you will get terms like this. Okay. So this is 2x minus 3 whole power 6. You will have 7 terms. Just cross check. Okay. This is power 5, so you will have 6 terms. This is power 6, so you will have 7 terms. Okay. Try all these problems yourself, and then cross check the answer here. Okay. Evaluate 96 power 3. Okay, so these are the another kind of problems, set of problems you will get. Either some number which is close to rounded 100 or 1000 they'll give, and power some power x. Okay, and otherwise approximation, you will see the approximation also later. Yeah. So 96, you can write it as 100 minus 4 whole power 3. So once you know that it is 100 minus 4 whole power 3, just expand it using a minus b whole cube. So 100 cube minus 3, 100 square 4 plus 300 4 square minus 4 cube. You simplify the terms, the answer you will get is 8,84,736. Okay, evaluate 102 to the power of 5. This is also similar. 100 plus 2, we can write it. 100 plus 2 whole to the power of 5. That is the answer. Evaluate 101 whole to the power of 4. Exactly same. 100 plus 1 whole to the power of 4. 99 whole to the power of 5, which is you can write it as 100 minus 1 whole to the power of 5. You have to do all these problems at least once. Okay, though they are looking very simple, just to make sure that your calculations don't go wrong and the practice on calculation, you have to do it once. Okay, the next one is, yeah, this is one interesting problem. You can use binomial theorem in such cases. Which number is bigger? Okay, he said using binomial theorem, this is the easiest way actually using binomial theorem. Okay, but even if it is not mentioned, you should better use binomial theorem to such problems. Okay, 1.1 whole to the power of 10,000 or 1000. Okay, so 1.1, you can write it as 1 plus zero point 0.1 whole to the power of 10,000. So if you expand it, first term is obviously 1 to the power of 10,000. Second term you will get NC1, right? 10,000 C1, which is 10,000 into 1 to the power of 9,999 into 0.1. Okay, and I will just stop it here. I just want approximation, right? I don't want exact value to uh, to check whether this number is greater than another given number. I don't need the complete one, right? So if I simplify this expression first to two terms, that's enough. Okay, to get the approximation. Okay, 1 plus 1000 plus some k. So which is 1001 plus k, which is obviously greater than 1000, right? So 1.1 whole to the power of 10,000 is always greater than 1000. Okay, so we can easily tell based on binomial theorem. Okay, this is another application of binomial theorem, which you can use it very many places for the approximation. Okay, now find a plus b whole power 4 minus a minus b whole power 4. Hence evaluate this value. Okay, first let us expand this. A plus b whole power 4 and minus a minus b whole power 4. Okay, here what happens is all the odd terms will get cancelled, right? All the odd terms gets cancelled and there will be three terms. Odd terms will be out of 5. Each one has 5 terms. 1, 3, 5 terms gets cancelled. 2 and 4 terms will be remaining and they are doubled, right? So it will become 2 times 4a cube b plus 4ab cube. You can directly write like this, or you expand each one and then cancel it. This is what you'll get. Okay, this is nothing but 8 times a cube b plus ab cube. Now you substitute the values here. Root 3 plus root 2 whole to the power of 4. Either you expand it and do, or just substitute the value here like this. Okay, so 40 root 6 is the answer. Next is x plus 1 whole to the power of 6 plus x minus 1 whole to the power of 6. Hence, evaluate this value. First is expand it. This is power 6 and plus value. So, all the even terms here, even terms x minus 1 to the power of 6, even terms will be negative. Those gets cancelled. And odd terms 1, 3, 5, 7 you will have. Okay. So, 2 times 1, 3, 5, 7 terms are here. First term is x power 6. Third term is 15 times x power 4. Okay. Fifth term is 15 times x square, then seventh term is 1. Okay, now substitute the values, you'll get 198. This is the answer. Okay, show that 9 to the power of n minus n plus 1 minus 8n minus 9 is divisible by 64 whenever n is a positive integer. Okay, yeah, one more thing where binomial application is used very much is to find the remainders actually. Okay, remainder theorem and binomial theorem, you mix it, you can actually solve the number theory problems very easily. Okay, so let's see how this can be solved. Okay, this can be solved with the remainder theory also, but you apply binomial theorem along with that, you can easily solve the problem. Okay, so first thing is expand 9 to the power of n plus 1. 9 I can write it as 8 plus 1 whole to the power of n plus 1. Okay, now this is what my expansion. 8 to the power of n plus 1, n plus 1 into 8 to the power of n plus 1 c2, 8 to the power of n minus 1, and the next term is 1, so I don't need to write that. Up to n plus 1 times 8 plus 1. Okay, here minimum value of n is 1. Correct, n is a positive integer, so minimum value of n is 1. every term has a minimum of 8 square in it, except the last two terms, right? If you see here, okay, if n is minimum 1, then, okay, up to this term, everything will have up to 8 to the power of 2 in it, okay. Every term will have 8 square, 8 square, 8 square minimum, and last two terms don't have 8 squares. This is n plus 1 into 8, this is just 1, okay. So all this rest of the terms I will write it as, okay, 8 square into k plus n plus 1 8 plus 1. This is nothing but 9 to the power of n plus 1, okay. Now this is equal to, simplify, 64k plus 8n plus 9. If I take 8n and 9 to the other side, it will become 9 to the power of n plus 1 minus 8n minus 9 equal to 64k, which means, okay, this expression 9 to the power of n plus 1 minus 18 minus 1 is divisible by 64, right? Because when you divide it, you will get the answer k. Okay, so this is another application where binomial theorem is very much used, remainder theorem. Okay, next. Prove that r equal to 0, sigma r equal to 0 to n, 3 to the power of r, NCR equal to 4 to the power of n. Okay, so let's see. Just expansion you have to do. Because 3 to the power of r, NC 0, first one is when r equal to 0, it is NC 0. When r equal to 1, okay, r equal to 1, it is NC1, 3 to the power of 1. Okay, you can actually, if you put it in proper way, it is NCR 3 to the power of r into 1 to the power of n minus r, I can call, right? 1 to the power of n minus r, I can call. In that case, this will become 1 plus 3 whole to the power of n. 1 plus 3 whole to the power of n. That's what is this expansion gives us, actually. Okay. So NC0, NC1, 3 to the power of 1, NC2, 3 to the power of 2, NC3, 3 to the power of 3, up to NCn, 3 to the power of n. Okay. So if I add 1 to the power of n to everything, okay, this is what it will looks like. Okay, which is nothing but 1 plus 3 whole to the power of n, that is 4 to the power of n. Okay, next. Let's do the miscellaneous exercise. If a and b are distinct integers, prove that a minus b is a factor of a to the power of n minus b to the power of n whenever n is a positive integer. Okay, it's given that n is a positive integer. So this is again a similar way we have solved a problem before. Okay, to find the remainder, right? Same way. So for a minus b is a factor of a to the power of n minus b to the power of n, we need to show that a to the power of n minus b to the power of n is equal to, correct? This is equal to k times a to the power a minus b. Okay, k can be any integer, positive or negative, doesn't matter. Okay, we need to show this is nothing but k times a minus b, right? Then it means that a minus b is a factor of a to the power of n minus b to the power of n. Okay, so first let's take a to the power of n. I can write this as a minus b plus b, a minus b plus b whole to the power of n. Okay, if I expand it, it will become nc0 a minus b. Why I choose a minus b as one group? Because I am trying to prove a minus b is a factor, right? If I have to, no, I don't know it will be a factor or not. If I have to prove a plus b is a factor, then I will take plus here and b I will put minus b I will put later. Okay. So NC0, a minus b whole to the power of n, NC1, a minus b whole to the power of n minus 1b, and so on. NCn, b to the power of n. Okay. Above expression, if you carefully observe, every term has a b, a minus b in it, correct? Up to last but one term. Okay. Only the last term don't have. Okay. Only the last term don't have a minus b in it. Okay. Which means at least the rest of the part I can write it as a minus b into some constant. Okay, so a to the power of n is equal to a minus b into some constant plus b to the power of n. Now, if I take this b to the power of n to the other side, a minus a to the power of n minus b to the power of n is equal to a minus b times k, which means it is divisible by this one, or you can call it a factor. A minus b is a factor, right? Next. Yeah, this problem you have solved a similar one before. You can do it yourself and cross check the answer. Similar, exactly similar. Okay, don't make a mistake. So you have to solve it at least once. Don't skip because problem is easy. Okay, while if you solve the easy problems, you will become perfect without doing any mistakes. Okay, your mistakes, number of mistakes will go down as you solve the problems. Okay, next. Approximation, that is similar. I can do this by 1 minus 0.01. 1 minus 0.01 whole to the power of 5. Okay, expand it here and then do it. Okay, I need only approximation, so I'll take first three terms which is asked here. First three terms I wrote, and then this is the approximate value. Next, expand using binomial theorem. So I said not only binomial, trinomial also is possible. They will ask questions on trinomial also, and more also they can ask as you go into engineering entrance exams. Okay, this is simple. Okay, you just group them. Basically, you have to group them and solve it. Whichever way you want to group, you can group. Okay, I see that this is x by 2, 2 by x, which are reciprocal to each other, so it will be easy. So I group these two. You can do anything and expand them power 4, so you will get 5 terms, and then each individual one you have to expand here. Okay, this is the square, this is the cube, this is the power 4. Okay, expanded here, and then carefully sum everything into. Okay, next, this is also exactly same as above, no different. You group two of them and then do the cube. Okay, so cube will have 4 terms, 1 2 3 4, right? 4 terms are there, and then you expand further each one, cube term, square term, and power 1, and then simplify them. Next, yeah, special cases. Let's see some special cases, some more applications where we can apply this binomial theorem. Okay, so yeah, this is the general term, 1 plus x whole to the power of n equal to, this is the value. Why I wrote this one is we can derive few special cases out of this. Okay, let's say x is equal to 1. X is equal to 1. Then what happens is 2 to the power of n is equal to nc0 plus nc1 plus nc2 up to ncn. Okay, so this is one thing you can use in many many problems later. Okay, if it is sigma nc I is from 0 to n, then you can replace it with 2 to the power of n. Okay, remember this. This is very important formula for many of the other problems. Okay. Yeah, next is if I replace x with -1, what happens is 0 to the power of n, which is 0, right? Okay. 0 is equal to nc0 minus nc1 plus nc2 minus, so all even and odd terms, you can actually separate them, right? So all odd terms, you can take them to the other side, or all even terms, you can take them to the other side. So what you can say is sum of even terms is equal to sum of odd terms. Sum of even terms equal to sum of odd terms. Okay. So this is one thing. If you really remember the Pascal triangle, each row is what this NC0, NC1, NC2 up to NCN represents a row, correct, in the Pascal triangle, which means within a row, all the even terms are equal to all odd terms. That's what we are trying to say. Okay. So hope you understand this one. This is also useful. Okay. Now, definitely, this is the most important thing is to know the general term. General term is TR plus 1, not TR. Again, I'm telling, which is equal to NCR, a to the power of n minus r, b to the power of r. Most of the problems in binomial theorem, you will get it on general term. Okay, most. Yeah, there are other applications and remainder, of course. Next, problems on middle term with specific power value and constant value. They will tell in 1 plus x whole power k, 10th term is x power 10 coefficient is this one. Then what is the value of k? Okay, what is the value of power? Something like that. Okay, we will do some problems. 1 or 2 we will solve here, and then rest I will cover in my shorts as well as videos I will make for the complex problems. Okay, the constant term in x plus a by x whole square, okay, is 6. This is how problems will come. Very simple problem I have taken. So we know that x plus a by x whole square. Okay, where is the constant term? X square you will have one term, a by x whole square you have one term, which is not constant because you have x. But the third term is 2 into ab, right? So 2 into x into a by x, which means 2a. So 2a is the constant term. So 2a is 6 is telling. 2a equal to 6, which means a is equal to 3. So these are the type of problems which you will get. Okay. Middle term, of course, if n is even, you will have odd terms. So your middle term is 2m cm. Okay. If m is odd, then you will have two middle terms, 2m plus 1 cm and 2m plus 1 cm plus 1. These two are the middle term coefficients. I wrote coefficients, but you can write the terms there. Okay. So such problems you are going to get. Let's do one or two problems more critical, and then we'll wrap up this class. Okay, using binomial theorem, find the remainder when 6 to the power of n minus 5n is divided by 25. Okay, here he did not give proof. Okay, these are the problems we'll get in engineering. What is the remainder when 6 6 to the power of n minus 5n is divided by 25. This is how the problem will come. He don't even mention using binomial theorem, right? So let's see. 6 to the power of n minus 5n. I can write it as 1 plus 5 whole to the power of n. Okay. Minus 5n. Okay. 1 plus 5 whole to the power of n, I can expand it as nc0 plus nc1 times 5, nc2 times 5 square up to ncn 5 to the power of n minus 5n. Now, if I see here, all these terms have 25 in it. All these terms have 25 in it. Only terms which don't have 25 in it is nc0, which is 1, and nc1 5, which is n 5n basically, right? This is nothing but 5n. So 1 plus 5n don't have 5n terms, rest all have 25 in it. Okay, so I can write this as 1 plus 5n, and then okay, 5n and minus 5n gets cancelled, so I will write it as 1 plus 25 times this whole number. Okay, so my 6 to the power of n minus 5n finally is left as 1 plus 25k. Okay, 1 plus 25k, which means the remainder is 1, right? If I divide this with 25, I'll get 1 remainder. Okay, so this is how you mix the remainder theorem and binomial theorem combinedly and solve the problems very easily. Okay, next. Okay, BT is very well used along with remainder theorem to find remainders and divisibility. Okay, both. Next. Yeah, this is the JEE problem. I have taken just to show what level of JEE problems we will get. Okay, this may be the easier problem I choose. More tougher problems, I will make more videos and shorts about it. Okay, so this is one of the problem. Fourth term of square root of x to the power of 1 by 1 plus log x to the base 10 plus x to the power of 1 by 12 whole to the power of 6 equal to 200. Fourth term, okay, he is asking, and x is greater than 1. What is the value of x? The fourth term of this one is 200. What is the fourth term? Fourth term is T4 is equal to 6C3. Careful, okay? Fourth term is TR plus 1. You will get NCR. So fourth term will become 6C3 because power is 6, and x to the power of 1 by 1 plus log x to the base 10 whole square. So I put to the power of half and whole to the power of 6 minus 3, x to the power of 1 by 12 whole power 3. Okay, now if I simplify this, I'll get this is nothing but 20 multiplied by x to the power of this value, same. Okay, and here it will become x to the power of 1 by 4. I can combine these two powers of x, okay, as 20 times x to the power of this whole expression, 3 divided by 2 times 1 plus log x to the base 10 plus 1 by 4, which is equal to 200. Okay, now this is nothing but 10 if I take 20 to the other side, and this will become 6 plus 1 plus log x, okay, times 4 times divided by 4 times 1 plus log x. Okay, now I'll take log on both sides. Okay, I'll take log on both sides. So what will happen is, okay, log 10 is 1, log 10 is 1 to the base 10, right? And this side I'll get this 6 plus 1 plus log x, which is 7 plus log x divided by 4 plus 4 log x times log x. Okay, because this is a power will become coefficient, right? Now, if I call one of the log x as k, okay, log x as k, then this is a simply, if I take this other side, 4 plus 4k equal to 7k plus 7k square. Okay, because here there is a k here, 7k plus k square. If I simplify, I'll get k square plus 3k minus 4 equal to 0. This is a quadratic equation in k. Solve it, factorize or whatever way you solve it. K equal to 4 or minus 4 or 1. Okay, now k is nothing but log x. So log x equal to 1 or minus 4 or x equal to 10 or 1 by 10 to the power of 4. But it is given that x is greater than 1. Okay, be careful about the conditions. Conditions they don't give just like that. Every condition is useful in engineering entrance exams, especially JEE and BITSAT. Okay, so x is given as greater than 1. So this cannot be a solution. 1 by 10 to the power of 4 cannot be a solution. So only answer is x equal to 10. Okay, yeah. So these are the kind of problems you will get in binomial theorem, and this is the theory. Very simple, very simple topic, which just takes 1 or 2 hours actually to completely do exercise everything. Then just do more and more problems. Okay, I will also make more videos and shorts about binomial theorem problems. Keep checking my channel. Thank you.